Welcome to the deep dive. Today, we're looking into something pretty fascinating. AI that can actually compose music. Specifically, a project called NotaGen. Now, I don't know about you, but I sometimes picture, like, a robot just hitting random keys.
Yeah, that's the common image, isn't it?
But this is apparently way more sophisticated and maybe even relevant to us non-musicians.
I think so, definitely. We're basically digging into how the techniques behind those, super smart chat AI things.
Yeah, LLMs, yes.
Right, how those ideas are being applied to music. So teaching a computer the language of melody, not just words.
Exactly. So the NotaGen team, they've taken these core concepts from language models, things like pre-training, fine-tuning.
And reinforcement learning, the AI feedback loop.
Right, and use them to generate classical sheet music. But the really interesting bit for us, I think, is how they did it. That method. Maybe it has uses beyond just writing music.
Well, absolutely. Because, let's be honest, getting a computer to write good music, stuff with real structure and feeling, that's hard.
Super hard.
You've got the problem of finding enough high-quality music data to learn from, for starters. And then, how do you even teach it what makes music musical? It's more than just the next note.
Totally. Okay, so this idea, using LLM training for music, it still feels a bit strange. We know they learn from text, tons of it. What was the leap? Why music?
Well, it's about seeing the similarity, I guess. Sheet music, especially in formats like ABC notation, it's fundamentally a sequence of symbols with rules.
Like grammar for music.
Exactly like grammar for music.
Yeah.
Notes, rhythms, structure, they follow patterns. So the thought was, if an AI can learn language patterns from text...
It could learn musical patterns from scores.
Precisely. That was the aha moment. Maybe it could learn harmony, melody, structure by just consuming huge amounts of notation.
Like a musical super reader.
Kind of. And the hope was this bypasses some classic problems, like not having enough clean data, or the AI just predicting note by note without grasping the bigger picture.
Okay, so NotaGen gets a musical education. Walk us through the syllabus. Let's start with pre-training. What's that like? Music 101.
Slight chuckle.
Yeah, pretty much. Think of it as musical kindergarten. NotaGen got fed a huge amount of music, like 1.6 million pieces.
Wow.
All in this format called ABC notation.
Okay, what's that? Is it like standard sheet music?
Not quite. It's simpler, text-based, uses letters for notes, numbers for timing, other symbols for things like key signatures. It's way easier for a computer to read than graphical scores.
Ah, okay. So less like reading tadpoles on lines, more like reading code.
Kind of, yeah. A musical text message, maybe. It's learning the absolute basic. C means this note, 4 means hold it this long. Basic musical grammar.
Gotcha.
And this giant data set gave it exposure to tons of different structures and styles, a broad foundation.
Makes sense.
And they did something clever. They transposed each piece into 15 different keys.
Why do that? It's like data augmentation. Makes the model more robust. It learns the pattern is the same, even if the notes are higher or lower, like recognizing A, whether it's big, small, or in italics.
Smart. Okay, so pre-training gives it the fundamentals.
Right.
What's next? Fine-tuning. Is that where it gets specialized?
Exactly right. After kindergarten comes, maybe, classical music college.
Like,
it was fine-tuned on a smaller but much more curated data set, around 9,000 high-quality classical pieces from like 152 composers.
So it goes from learning all kinds of music to really focusing on the classical masters, like learning Bach and Mozart specifically.
That's the idea. It hones in on the specific styles, the conventions, the typical sounds of classical music, Baroque, classical, romantic periods.
Different eras, different sounds.
Yeah, and different instrumentations too. Is it for piano? There's string quartet, full orchestra. The fine-tuning helps to learn those distinctions.
I saw something about prompts. Period composer instrumentation prompts. How does that work?
Oh, yeah. Those are like specific instructions. During fine-tuning, the data was tagged. So a piece might be tagged Baroque Bach, Johann Sebastian keyboard.
Okay.
And the model learns to associate that tag with the style of the music it's seeing. So later, you can give it a prompt like classical Mozart chamber.
And it knows what kind of music to aim for.
Exactly. It's learn the characteristics linked to those labels. It's like giving it a very specific request.
That's really cool, like a detailed creative brief for an AI composer. Okay, basics learned, specialization done. Now for the really cutting edge part, reinforcement learning with a musical critic. What on earth is that?
Yeah, this is where it gets maybe the most interesting and possibly where the most valuable tech lies for other fields, too.
How so?
Instead of having humans listen and rate the AI's music, which is slow and subjective.
Totally. Who decides what's good?
Right. They used another AI, a model called CLaMP. Think of it as an automated musical expert or critic.
CLaMP-2. Okay, what makes it an expert?
Well, CLaMP-2 is designed to understand music in different formats. ABC, MIDI. It's trained to pick out what they call semantic features.
Meaning?
Things like the style, the complexity, the instrumentation, the mood almost, the core essence of a piece. It can tell if something feels Baroque or sounds like it's meant for an orchestra.
Okay, so it can analyze music deeply. How does it act as a critic for NotaGen? Does it give reviews?
Sort of. They created something called the CLaMP-2 score. It measures how similar NotaGen's generated music is to real classical music. Based on those features, CLaMP-2 understands.
Ah, so it compares NotaGen's homework to the masters.
Pretty much. If NotaGen is asked for Baroque, CLaMP-2 compares its output to known Baroque pieces and scores it on stylistic similarity.
Like an AI taste tester. Needs more counterpoint for proper Baroque.
Essentially, yes.
Okay.
And this score is used for reinforcement learning. They use a technique called DPO, direct preference optimization.
DPO, okay.
NotaGen generates some musical options. CLaMP-2 scores them. Based on the scores, some are labeled chosen, good, and some rejected, less good.
So CLaMP decides which ones are better.
Effectively, yes. And NotaGen learns from these preferences. It adjusts how it generates music, its internal policy, to make more stuff that gets the chosen label and less of the rejected stuff.
And this is all AI-driven, no human listening required at this stage.
That's the clever part. The AI learns from its AI critic. They used a variant called DPO positive, apparently, to make it more stable. And it can be iterative. The model learns, gets better, generates improved music, and then learns from those improved generations.
Wow, it's like AI self-improvement. The AI is literally teaching itself to be a better composer based on feedback from another AI.
Exactly. It's a powerful feedback loop.
Okay, that's mind-bending. So NotaGen gets good at classical music, but back to the big question. Why should someone listening, maybe someone in marketing or finance or education, care about this? What's the real-world takeaway, the valuable technology for everyday work?
Right, the so what factor.
Yeah.
I think the most valuable piece isn't just the music generation, cool as that is, it's this three-step recipe.
Pre-train, fine-tune, AI feedback.
Yes. Learning general patterns from huge data, specializing that knowledge for a specific style or domain, and then using automated AI-driven feedback to continuously refine the output based on desired characteristics. That process is incredibly versatile.
Okay, so how could that recipe apply elsewhere? Give us some examples outside music.
Well, think about generating structured reports, maybe financial summaries or technical documentation.
Okay.
You could pre-train an AI on millions of documents to learn general language and structure, then fine-tune it on, say, successful quarterly reports from your industry.
So it learns the specific jargon, format, tone.
Exactly. Then you could use an AI critic, maybe one trained to check for compliance, clarity, or brand voice, to provide feedback using that DPO-like method. The system learns to generate reports that are not just coherent, but also meet specific quality standards automatically.
Huh. So automating compliant or well-styled document creation, I can see that being useful. What else?
Personalized learning, maybe?
Sure.
Pre-train on general knowledge, fine-tune on educational materials for a specific subject,
Yeah.
then use an AI critic that assesses if the generated explanation or exercise matches a student's known learning style or difficulty level. The system learns to create truly tailored educational content.
Wow, okay. Custom learning paths generated on the fly.
Or design, train on vast libraries of designs, products, graphics, whatever, fine-tune on a specific brand's aesthetic or a particular product line.
And the AI critic checks if the generated variations fit the style guide.
Precisely. Or even marketing copy. Train on general ads, fine-tune on campaigns for a specific demographic, use an AI critic to evaluate persuasiveness or tone for that audience. The core idea is learning a style or standard and then generating novel things that adhere to it, with AI ensuring quality control.
So the really valuable tech here is that process for creating AI that understands nuance, style, and structure in complex information and can generate new, high-quality examples within those rules.
I think that's exactly it. NotaGen doing well against other models, even getting decent ratings against human music, proves this combination of techniques works for capturing subtle qualities. That ability to learn a style and generate within it, guided by AI feedback, that's the transferable insight.
It's like a shortcut to expertise, almost. Learning the rules and feel of something complex from data, then refining it automatically.
Yeah, it's a powerful paradigm for generation and refinement.
Okay, that puts it in perspective. So wrapping up, NotaGen's cool because it applies these LLM training ideas to music successfully. Pre-training for basics, fine-tuning for classical style, and this really clever AI critic feedback loop with CLaMP-2 and DPO.
A solid summary.
Yeah.
It shows real progress in generating musically coherent output.
But the bigger picture, the thing to maybe really ponder, is how that process, learn broadly, specialize, refine with AI feedback, could be applied elsewhere. So maybe the final thought for everyone listening is this. If AI can learn the rules and aesthetics of classical music well enough to compose it, what complex systems, styles, or creative processes exist in your world? Could this approach analyzing data for patterns, specializing, using AI feedback, help understand them better, or generate new, effective solutions, or just improve quality in your own work?
It's a really interesting question to consider. Maybe it's not about writing symphonies, but about writing better code, designing more effective user interfaces, crafting clearer instructions, applying that learn, specialize, refine loop.
Yeah. While AI composing might seem niche, the underlying this method for teaching AI style and structure and quality feels like it could pop up almost anywhere.
Definitely something to keep an eye on. It's a potent reminder of how AI can help us understand and create in increasingly sophisticated ways.
Absolutely. Well, that's our deep dive for today. Thanks for tuning in.